Hey, this is Mr. Warden. This is the Geometry Exit Ticket 29.1 video key. And again, we are reviewing some algebra concepts about radicals and quadratics to get you ready for Chapter 9 when you get there. And so here we go. So they are similar questions to the do now. Now, once again, I don't want calculators and I don't want decimal answers, and I want you to just give it a try. So C is the square root of 72, but we can break 72 into 9 times 8. We can further break that 8 into a 4 times 2 if we want. We also could have broken it into the square root of, I didn't like that very much at all. Could have broken that into the square root of 36, since 9 times 4 is 36 times 2. And then you can pull that 36 out of there, and the square root of 36 is 6. And then we're still left with the square root of 2, and this is the exact form. Okay, your decimal rounded version is not an exact form. And of course, it's a plus or minus there. Okay, so let me put that in here. So we can break up C into the square root of 9 times 8 times 2. I'm sorry, what am I saying? 9 times 4 times 2, okay, because 8 is 4 times 2. We can further rearrange that into the square root of 36 times 2, and then that becomes plus or minus 6 square root of 2. And that is your most simplified version and your exact version. Now, same deal with 32. We can break 32 into the square root of 16 times 2. Okay, you could have also broken it up into 2 times 2 times 2 times 2 times 2. But 4 of those 2's would multiply out to 16. So this ends up being 4 root 2. And that's, of course, plus or minus. Okay, so I'll put that in here. So D ends up being square root of 16 times 2. If you didn't see that, you might have seen 4 times 8, and then you could break those down. But basically, your goal is to see if there is, what's the largest perfect square that's hidden within there as a factor. And the largest one is 16. So we're going to say that equals 4 square root of 2. And then we want to go over here and put in the plus or minus to indicate that there's actually 2 answers to the square root of 32. The principal one is positive 4 square root of 2, or 4 root 2, but there is also a negative option. For these, you're going to have to simplify what's underneath the square first. So you're going to square 3 and you're going to square 4. So we're going to have the square root of 9 plus 16, and that's going to equal the square root of 25, which is 5 plus or minus. Now, sometimes you're only going to care about the positive one, but you want to hang on to the possibility it could be negative, because sometimes that will still be a relevant answer in a geometry problem. So we're going to have square root of 9 plus 16, because you're squaring 3 and squaring 4, and that's going to equal the square root of 25, which equals plus or minus 5. And then D, similarly, we're going to simplify what's inside here first. So 5 squared will be 25, and 12 squared will be 144. And we can add those together, and we get the square root of 169. And you may or may not know this, but the 169 is a perfect square. It is the square of 13. So our answer is plus or minus 13. Okay, the next one, you remember in the do now, we talked about rationalizing denominators. So what we're going to do is we're going to multiply this one by a version of 1, which will be the square root of 2 over square root of 2. And this one over here, we will multiply by a version of 1 that'll be the square root of 3 over the square root of 3. Okay. Now, when we do this one, this up here is going to end up being 6 root 3, which is just a shorthand way of saying 6 times the square root of 3. And down here, that's going to be 3. And then we can reduce this because we can factor a 3 out of that and that, out of the 3 and the 6. And we end up with simply 2 root 3 as the answer for D. For C, what we end up, I'm going to go, up here. I wanted to use red. We'll use red. So 4 times root 2. 4 times root 2. And that's going to be over 2. And once again, we can reduce. We can factor a 2 out of top and bottom, and that becomes 2. So this is 2 root 2, like that. So I'll put that into the answer. So C, we ended up with 4 square root of 2 all over 2, and we can reduce that to 2 square root of 2. D, we're going to end up with 6 square root of 3 all over 3. And we can reduce that to 3 square root of 3. And we're done with that. All right, last one. Okay, this one, you're going to be applying what you've just done with some stuff in this one here, where you had to simplify what's going on with that square root, because what you're going to find out is you're going to have some like terms. So I'll deal with the first one. Use red. So square root of 12 is going to be the square root of 4 times 3. And the square root of 27 is going to be the square root of 9 times 3. So we have found a perfect square in the midst of all that. So that ends up being, pull that out, that's got a 2, and that's got a 3. So 2 plus 3. Okay, we can pull those out, and you're still left with a square root of 3. Square root of 3 like that. And so that becomes 5 square root of 3. Okay, now we're going to deal with just the principal root for this one. So that's going to be, C will end up being square root of 4 times 3 plus the square root of 9 times 3. And we can simplify that into 2 square root of 3 plus 3 square root of 3. And we can then make that 2 plus 3 times square root of 3. And that ends up being simply 5 square root of 3. Okay. And then D, we can do a similar thing. So 72, I'm going to do this just in the text. 72 is the square root of, we already worked out, 36 times 2. And 75 is the square root of 25 times 3. We've got a perfect square in there as well. And then 48 is 16 times 3. So we can say that that is the square root of 16 times 3. And now we can simplify that further. Break out the square root of 36. So that'll be 6 square root of 2. And then break out the square root of 25. That becomes a 5. So 5 square root of 3. And then we're going to break out the 16 from the square root jail, and it becomes a 4. So we got 4 square root of 3 minus 4 square root of 3. And we can further simplify all that into 6 square root of 2 plus, now I'm going to say 5 minus 4 square root is the square root of 3. And that will equal 6 square root of 2 plus 5 minus 4 is 1. So I'm just going to call that square root of 3. I could put a 1 in there, but we don't generally do that. That's what that is. Okay, hopefully that was helpful.